For thousands of years, people have dreamt of and searched for the fountain of youth. It may have eluded the ancient Greeks and 16th century Spanish explorers, and in the 20th century, the idea of turning back the clock might have been resigned to science fiction. In recent years, though, scientists have slowly but surely been understanding how our bodies age at a cellular level. And there's increasing evidence that some drugs might be able to reverse that process, giving humans longer and healthier lives than ever before. What's more, you might already know people taking some of these drugs. So could we really drink from the fountain of youth in our lifetime? With me today, hopefully not to crush all our dreams, is Dr. Andrew Steele, a scientist, campaigner and author of the book Ageless, the new science of getting older without getting old. Hi, Andrew.
Hey, how you doing?
Andrew, I'd love to know when you meet people for the very first time and you say to them, my work focuses on ageing, what sort of questions do they ask you?
All kinds of things. I think one of the most popular is obviously, what's the magic pill? Have you got one for me? Where can I sign up for the trial? But another question you get surprisingly often, and this sort of shocks me in a way, or it did initially at least, you get a lot of really complicated, knotty ethical questions. So people ask, what about overpopulation? Haven't we already got a planet that's heaving at the seams with people? And if we have people living longer, aren't we going to have an even larger problem? And, isn't this only going to be available to the rich? But I see it as just an extension of modern medical research. It's much the same as being a cancer researcher or a heart disease researcher. And when, if I introduce myself at a party and say, hey, I research cancer, everyone says, fantastic, it's brilliant, I really want to cure cancer. And yet, if you talk about the idea of treatments for aging, let alone a cure for aging, what even might that mean? People have a very different emotional sort of ethical reaction to it, and I find that absolutely fascinating.
Andrew, this just might be a sign of how superficial I can be, but when I heard about us doing this podcast together and I thought about anti-aging, of course I thought about how I look. And I think a lot of people also, because of the success that the beauty industry has in marketing anti-aging treatments, that's where we go when we think about anti-aging. But that isn't what we're going to be talking about today. What aspects of aging does your work focus on?
Well, the idea is that actually those external cosmetic signs are clearly an aspect of aging, but the same processes that give us wrinkles, that give us grey hair, are also happening inside our bodies on a microscopic scale. And those processes massively increase the risk of disease. They increase the risk of cancer, dementia. All of these are called age-related diseases because the single biggest risk factor isn't smoking, isn't diet. It is ultimately the accumulation of the cellular molecular damage and changes that go along with aging. And that means that, say you're 30, you can have a terrible diet, you can smoke, you can do all the wrong things health advice-wise, but you're still much safer from a sort of medical point of view than someone who's chronologically 80 and has led a completely clean lifestyle until that point, because the risks that are associated with aging massively increase their risk of disease. And it's not just disease, it's the wrinkles and the grey hair, as we've mentioned, but it's also the frailty, it's the incontinence, it's the impotence, all of this sort of constellation of things that go wrong with our bodies as we get older. And actually, if you add up all of those different things, aging is responsible for more than 2/3 of deaths globally, which might sound a bit weird, but it means over 100,000 people die every single day. And that's because of cancer, it's because of dementia, it's because of heart disease, it's because of the increased risk of dying of other things like infections as you get older. And if you add all of those together, you find that aging is our single biggest challenge, I think.
Andrew, why is it that all over my social media feeds at the moment, I'm seeing wellness experts and fitness people and beauty experts as well talking about their biological age? What do they mean?
Well, that's because there have been advancements in the science in the last sort of 5-10 years that have allowed us to come up with various measures of how old you are, not chronologically, so not how many candles there are on your birthday cake, not how long ago you were born, but biologically. If we look down at these fundamental cellular and molecular changes, we can measure some of those changes and we can work out not just how old you are from how long ago you were born, but also your risk of disease, your risk of frailty, all these other things added together. And actually one of the most popular are something called the epigenetic clocks. So to do one of these things, you might do a blood sample or a saliva sample. And then the scientists will test some markers on your DNA. And we know that these markers change as you get older. And these changes seem to be related with how long you're going to live. When the scientists first did these experiments, they were just trying to predict how old people were, see if, they could even detect these changes. But what they noticed was that if I, say I did an epigenetic age test, I'm 39. If the scientists, went away and took my saliva sample and it came back as 45, they noticed that people with this accelerated epigenetic aging, as it's called, had a higher risk of disease. They had a higher risk of dying than people who had an epigenetic age that was equal to or less than their chronological age. Now, these are hugely exciting research tools because they're going to give us the opportunity to really measure what's going on in biological age. But I think they're probably not quite ready for consumers to use yet. We don't fully understand what's going on under the hood. And that means that they're not really very actionable either. Because, for example, if I did do that biological age test and it came back and told me I was biologically too old, what would my advice be? It would be, do some exercise, trying to get a healthier diet, get a bit more sleep, all these kinds of things that would give exactly the same advice if it was someone who was biologically the same age as their chronological age or even biologically younger. So at the moment, there's not much they can actually advise you to do based on these tests. But in the longer run, I think they're going to be really, really important from a research perspective to understand what's actually happening as we grow older.
Andrew, when I think about ageing, I think about my back and my knees that didn't used to be sore that are now, the fact that I'm starting to get grey hair, the wrinkles that are appearing on my face. That's what ageing means to me, and I'm sure to a lot of people. But what exactly is it? I mean, what is happening at a cellular level?
Well, it's a variety of different things. We now know that aging isn't one single process, and this is actually the reason we're never going to have some single magic pill that allows us to just completely solve the problem. But what we understand is we can break it down into what are called hallmarks of the aging process. The first hallmark is the sort of the most fundamental, the smallest microscopic one, which is looking at damage to our DNA. Now, our DNA, as you know, is the instruction manual that's found at the centre of every one of our cells. But as we get older, that instruction manual effectively accumulates typos because there are various processes from the air that we breathe can actually damage our DNA, but when cells divide, they have to copy that DNA, and they can make essentially copying mistakes. And over time, these tend to accumulate. If we zoom out a little bit further, we can see the fifth hallmark is what are called senescent cells. And senescent is just the biological word for getting older. It's sort of the technical term. And these are cells that have divided too many times. Maybe they've got a bit of DNA damage. They've got a variety of things wrong with them. And so what they do is, in order to protect the body, they stop dividing. But unfortunately, when they stop dividing, they actually eventually accumulate in our bodies and can cause all kinds of damage that can go on to accelerate the aging process more broadly. And if we zoom out even further, the last hallmark on my list is the aging of the immune system. And I think we're all reminded of that particularly starkly in the last few years because of the COVID pandemic. We know that older people were dramatically more likely to die if they got a COVID infection than a younger person was. But the immune system also has a variety of other roles around the body. It's not just for fighting disease. It also seeks out cancer cells. It also actually clears out those senescent cells I was just talking about. So as the immune system weakens, it causes a whole range of other issues. These hallmarks are all very interconnected as well. But the hope is, because these are the fundamental drivers of the aging process, if we can go in and intervene in those, then potentially we can stop not just one, perhaps many or even all of the age-related diseases with a few treatments.
Andrew, I found it really interesting that you describe ageing as the biggest humanitarian crisis facing us. How did you come to that conclusion?
So 150,000 people die every single day on planet Earth of a variety of things, but over 100,000 of them die of aging. More than 2/3 of people die because of the cancer, because of the heart disease, because of the dementia, because of the increased risk of disease, and so on. So what that means is that it's by far our largest cause of death. And actually in the rich countries, it's even more extreme than this. In a country like the UK or Germany, about 90% of deaths are caused by the biological process of aging. So there's just no argument that this is our single largest cause of death. And as life expectancies rise globally, countries in the developing world are rapidly catching us in the rich world up. So that's the first thing, this huge number of deaths. But it's the way those deaths happen. Maybe death's not so bad. You don't have to be afraid of dying to want to do something about this. It's because as you get older, there's this huge decline that comes along with it. You've already mentioned your knees and your back, but obviously these things get much worse. If you're in your 70s or your 80s, that frailty can really start to kick in and impact on your activities of daily living. You can't get around the house, you can't go on holiday, you can't play with your grandkids, you can't engage in your hobbies. And then the way these diseases kill you is often drawn out and very unpleasant, with cancer, it can be years of grueling treatment before you finally die. And so I think aging is our greatest cause of suffering as well, not just death. And that's why I think it's our greatest humanitarian challenge. There's just nothing else on the planet that causes this degree of suffering.
I mean, I'm dreading that, Andrew, the fact that the pain I've got in my knees and my back now are only going to get worse as time passes. Andrew, can you also help us understand what it is we're exactly trying to achieve here? Like, what is the difference between lifespan and health span?
I think this word health span is really, really important because nobody, and this includes the scientists working on the biology of aging, want to drag out that period of ill health at the end of life. And so, we don't just want to extend how long you live, but we want to extend how well you live as well. And that's this idea of health span. It's not just how long, but it's how long you spend free from disease. We want to make that health span as long as possible. And the good news is that basically every way that we know of to extend lifespan also extends health span. So, we can just look at this from everyday life. We know that if you exercise, if you eat well, if you don't smoke, all of these things will make you live longer, but they also extend that period of life in good health, before you get sick at the end of life. You can also look at an example of human centenarians. So these are people who live to over the age of 100. And what you find is that the average person who lives beyond 100 lives independently until they're 100 years old. And what this shows us is that there's something in their biology that isn't just extending their lifespan. It's not making them old and frail for an extra 20, 30 years that, more than the rest of us have to deal with. They're actually delaying the aging process by that period of time instead. And so hopefully, if we can come up with a way to bottle that, whether that be through senolytic drugs or one of these other approaches I've talked about, then we're going to have potentially, the ability to keep ourselves healthy for longer. And I think that's what all of us really care about.
So now to the big question, what we all really want to know. How can this all be applied to actually slow down our aging?
Well, the idea is that by looking in the lab at these various changes, we can come up with ways to intervene in those changes. And I think the most intuitive one to explain is actually those senescent cells that I talked about earlier. So these are cells, they're old cells essentially, they build up in our bodies as we get older. Our immune system gets less efficient at clearing them out, which is one of the reasons, but also they're just accumulating in greater and greater numbers, and they drive a whole range of different diseases. So scientists thought, well, if these things are growing in number as we get older, then maybe if we could clear some of those cells out, that could help. And so in the sort of 2010s, scientists were looking for various different ways that they could clear out these cells. And they happened upon a couple of drugs. There's a drug called dasatinib, which is normally used as a chemotherapy drug, and something called quercetin, which is a flavanol. It's it's sometimes used as a nutritional supplement, normally found in fruit and veg. And they found that by combining these two things together, they could actually remove the senescent cells from mice, but leave the rest of the cells of their body intact. And they found that by doing this, they essentially made the mice biologically younger by a number of different measures. So the first thing is they live a little bit longer. That's a good start. But it wasn't that they were dragging out that period of frailty at the end of life. These mice were acting in a younger way as well. Because you do not need to be an expert mouse biologist to see. They just look fantastic. They look like different mice. They've got thicker fur, they've got less grey fur, they've got plumper skin, they've got shinier eyes, they've got less age-related weight gain. They just look younger. And hopefully, we can start putting these through trials in humans and create something that humans could be taking as well.
So there's no drug currently, Andrew, that's licensed to broadly treat ageing, but are there some that are showing promise?
There definitely are, and I think it's going to be a bit of a challenge at first to get a drug licensed for aging per se, because you have to demonstrate somehow that it makes people live longer and healthier. And that's going to be a long trial, right? Humans live 70, 80 years or more, and that means that particularly if your drug works, that trial is going to take even longer. One of the drugs that's really showing promise in the lab is a drug called rapamycin. In 2009, scientists showed that you could give it to mice. You could even wait until the mice were pretty late in life, so they waited till they were 20 months old, about 60 years or so in human terms. They gave them some rapamycin, and they found that they made them live longer. Maybe 10-15% longer, in fact. And again, they weren't dragging out that period of frailty. They were keeping them healthier for longer as well. And what's really fascinating is that this is a drug that humans are already taking. They're not taking it in the longevity context, but what they're doing is taking it as a transplant drug. So if you've had an organ transplant, then one of the big risks from that transplant is that your immune system will recognize that that organ doesn't come from your body and attack it. So you need to suppress your immune system. And rapamycin was actually first developed as a really effective immune suppressing drug. But it turns out if you take it at much lower doses, it might have an effect on lifespan. Now, this probably isn't ready for the prime time. I don't think people should be going away and start popping back the rapamycin pills. We haven't got the proper randomized controlled trial data I would like to see before I, start recommending this to people to actually take for aging. But the fact is, this is a drug we've been using for a couple of decades now. We understand its safety profile. We understand how it works. We've got really solid evidence that it works in the lab. So we just need to start doing some more experiments and see if this could be used to slow down aging in people as well.
Andrew, what other therapies are out there that people are getting excited about?
I think one of the most exciting that's really causing a buzz at the moment is something called cellular reprogramming. And this is a fascinating therapy. I'm actually a new dad. I've just had, my wife and I have just had a baby. And this is a really interesting thing from a biological point of view, because obviously it's a miracle in a number of ways. But thinking about it from the possibility of aging biology, then I'm 39, my wife's 33, and yet our baby is 0 years old. Now, I know that sounds really obvious, but bear with me here. She's been born with, babies who are born to 30-odd-year-old parents have the same life expectancy as babies who are born to parents in their 20s, or even babies who are born to parents in their teens. So clearly, even though she was born from old cells, she was born from a 32-year-old egg cell from my wife and a 39-year-old sperm cell from me, somehow that combination has managed to reset the biological clock, and she's got a normal life expectancy ahead of her. So in some ways, biology has already solved the aging process. The question is, can we somehow come up with a way to bottle that and give it to people? And in the lab, that has actually been achieved. We can do this process called cellular reprogramming, where we can turn back the biological clock of a cell. And this was first used for stem cell research. So scientists were trying to find out how to turn a regular cell, you could get a cell from my skin, for example, and turn back the clock and turn it into a stem cell that could then become any kind of cell in my body. But scientists noticed that while they were turning back the developmental clock on these cells, it also turned back the aging clock, or at least seemed to. And so they tried this experiment in whole mice. They found that it didn't reverse the mice's cells all the way back to being stem cells. It just made them age a little bit more slowly. And there's huge commercial interest in this now as well, because it's such an exciting technology. The biggest sort of startup in this field is called Altos Labs, funded by, amongst other people, Jeff Bezos. And they've got $3 billion together from investors to try and investigate this technology.
This is all so cool, Andrew, but the obvious question as well is, when could this all be a possibility?
This, I think, comes to a question of funding. So I think that the question that journalists love to ask and scientists hate to answer is, how long is it going to be? And I think part of the reason for that is that thinking of it as a number of years away is the wrong way to think about it, because we have to actually try to get this research to work. And to take the example of the US is one of the few countries in the world that has an actual government research body specifically devoted to looking into aging biology. And if you look at the aging biology division of the National Institute for Aging, so this is the part that's doing the kind of research that I care about, their budget is about $300 or $400 million a year. Now that sounds like a lot of money to you and me, but actually, if you think about it, it's just over $1 per American, which is wild because aging causes 85% of American deaths. I think this is going to happen in time for most people alive today. We've got AI, we've got loads of new tools arriving in biology and gene editing and stem cell therapy. That's a huge amount of time for those developments to happen. And if we can do the science, if we can invest in that science, it could definitely arrive, well before all of our 80th birthdays. So that's in plenty of time to make a difference to the trajectory of our aging.
I mean, getting some exercise and eating well, these are all things we've been told for years by lots of people. A good night's sleep, tricky for you at the moment, Andrew, with a newborn, I know.
Absolutely, yeah.
Yeah, we do know these things. Is there not one other thing that you're doing?
I think the most interesting unconventional piece of advice, which comes from understanding the aging biology, is actually brushing your teeth. And there are a variety of good reasons to be brushing your teeth and, avoiding painful visits to the dentist and so on. But actually, we've discovered there's this connection between the biology that's going on in your mouth and the biology in the rest of your body. So when you get tooth decay or when you get gum disease, those are bacteria in your mouth that are, invading or trying to take control in there. And we know that the reason dentistry is in some ways so medieval, they go in there with a drill and they remove the infected bit of tooth, is because that's a battle that your immune system can never win. I already mentioned aging of the immune system is one of those hallmarks of aging. Actually, one of the ways in which it ages is it constantly gets a little bit paranoid. It's sort of looking over its shoulder all the time. It's sort of this increasing chronic inflammation is what it's called. And because this is essentially what's going on in your mouth, because the immune system is fighting this battle against these bacteria that it can never quite win, we now know that inflammation in your mouth can drive inflammation in the rest of your body. So it can increase the risk of heart disease, increase the risk of stroke, all of these heart-related complications. There's even some evidence that it might be able to increase the risk of dementia if you have, bad teeth and bad oral health generally. I think the evidence is compelling enough that it definitely gets me, flossing, trying to clean between my teeth, using, brushing twice a day, all this sort of standard dental advice. But just realizing that has a connection to the aging process has really, redoubled my efforts to keep my teeth clean.
Dr. Andrew Steele, that is the best bit of advice anyone has given me for a long time. Thank you so much for joining us on The Global.